How's it going, physics group? Usually I'm facing the other way when I'm talking about the board, but I want to kind of try and do a little physical demonstration today. So welcome to kind of dynamics part 2. We're going to focus this week basically just on friction, how it interacts with forces, how it interacts with motion, how it interacts with acceleration, and really want to kind of delve in deep to working with friction and understanding it. So I guess the first thing is, what is friction? And you guys all already know basically the basics about friction. It is when two objects are rubbing against each other and there's going to be trying to be some kind of motion. So either you're trying to pull something and it's on a carpet and it's hard to move, that is obviously a reason because of friction, or again trying to stop a car with the tires on the road. But basically any two things that are rubbing each other when we're trying to have motion, there's almost always going to be friction. We're almost never in a frictionless state. Even in the air, you can kind of have air friction, or what we call air resistance. But you're never really going to get two things that are perfectly smooth. The only thing that would be very, very close would be like a block of ice on another perfect sheet of ice, where there's almost no resistance or no friction at the point. But most of you already know kind of the understanding of friction. But we also, I'm going to take it to the next step and say, like, is friction kind of a uniform thing? Is there an easy way of figuring out right away? Well, friction has kind of a variation. Like, there's some things that have strong friction on other substances, and there's some that have less. And so I'm going to give you a little demonstration here. We have just this table here, and I have 3 different objects that are kind of ish close in weight. This one's the one that's not really close in weight. We have this, it's a pretty smooth plastic. I'm not using the actual eraser part, I'm using the plastic part. And if I push, it goes pretty far. You can see it's behind the board over there. I have now a box. This is cardboard. And if I push this with about the same force, you can see it gets most of the way there. And now I'm going to use the rubber side of a hole punch. If I push this, again, it's not getting anywhere close to where those two are. So why is that? Why is this one going not nearly as far as the other two? And it's because of what we're going to call a coefficient of friction. I'm going to do some work on the board over there in the next video. But basically a coefficient of friction is kind of the percentage it's going to slow something down. We use a decimal for it, but I like to talk in percentages for understanding in our own heads. So when I want you to imagine like a person on ice with skates. If you push, you can glide fairly far, like you're going to go pretty far. That's because that coefficient of friction is really low. Let's say friction only takes away 5% of your actual force. So I give a force on ice, I'm going to glide quite a long time because that friction is not taking away a lot of the force that I gave. Where, let's say I push this on the table, friction is doing a lot. It's a rubber bottom, like on a table. I can push pretty hard. It's really not going to go that far because friction, there's a high percentage between the two objects there. And so let's say there's 80%. I only got 20%. Like if I were to have 0, 0, it would go on forever and ever, obviously, because again, when we talk about law 1, an object in motion wants to stay in motion unless acted upon. Friction is what's acting upon here. But we're going to say it's taking 80% away. Like I only get 20% force out of there because of friction. That's in this example, the rubber. So we're going to kind of work with coefficient of friction and how to figure out. So in my next video, we're going to go through the formula for finding the force of friction. How much force is friction actually applying to something? Okay, and we'll use the coefficient of friction in there. So that'll begin in the next video with the formula and some examples. So now that we kind of understand a little more of the basis though, and we kind of, hopefully you kind of get the idea of what coefficient of friction is. It's a percentage of something that's slowing it down because of whatever two objects are rubbing. And again, that coefficient, that percentage is going to change depending on what two objects are rubbing. Again, if I have rubber shoes on the ground, or if I were to put on like little plastic booties, again, I'm going to slide more in the plastic than I'm in the rubber. So different things are obviously going to have different percentages, and so that coefficient of friction, that number we're going to use, is going to be different each time. The last thing I want to talk about is the difference between mass and weight. They sound the same if you say, hey, I weigh this much or I have a mass of this much. I know we say that you weigh a certain amount and we talk usually in pounds, but technically in the scientific world we don't use pounds at all. We always use kilograms, which is mass, and then we use weight. Weight is actually measured in newtons. And so let's use an example. Let's use like an average human kind of being in the sense of, let's say someone has 60 kilograms. That's a bad marker. Let's try that one. Let's say someone is 60 kilograms. Okay, and if you have no idea what kilograms are, it's to get from kilograms to pounds, you times by 2.2. So this person would be about 130 pounds. So this person, 60 kilograms, how much force are they going to put on the ground? Like, again, I'm standing here. Force of gravity is obviously pushing me down. So how much force am I putting on the ground? Well, that's where weight comes involved. And if you guys remember from last week, we can actually find the force of that person on the ground. We have a mass of 60 kilograms, and we also always know the acceleration of gravity. The acceleration of gravity is always 9.8. So to find the weight, which is the force of me on the ground, you're always just going to take the mass and times it by 9.8. So I'm just trying to look at my calculator that's around here. I'll use my phone for now. Handy dandy calculator on my phone. Should have been a little more ready for that one, but that's okay. We have 60 times 9.8. So 588. Basically, this person has a weight of 588 newtons. That's how much force they are applying to the ground. And that's going to be important for eventually other things if we're talking about like, can this structure hold this person up? Like if the structure can only hold 500 newtons, this person's too heavy. There's too much force that they're applying on the ground, okay? So that's the big difference between mass and weight. Mass is always in kilograms. If something weighs by newtons, and the nice thing is we can go the other way on this one too. I'm just trying to look at my, here it is. I can go the other way because sometimes there'll be a thing that says it weighs, and let's do an example. Let's say there's an object that weighs 120 newtons. And then eventually you have to find how fast something is moving. And when you want to, I'm going to get back on the screen here. If you're trying to figure out how fast something is moving, again, you need a mass, not the weight, you need the mass. So if it says something weighs this much, but you need a mass, it's kind of annoying. If you're going from weight back to mass, just divide it by 9.8. So take this 120, divide it by 9.8. I guess I'll do that on my phone right now. There we go. Okay, so we have 120 divided by 9.8, and you get 12.24 kilograms. 12.24 kilograms. All right, so there's a little intro into friction, or just our basics, and what kind of coefficient of friction means. Here's our difference between mass and weight. In my next video, I'm going to go over what the formula is for friction, a couple examples of how to go through it. We're going to have 2 videos today on Tuesday. I'm going to put the other 2 up on Wednesday, hopefully morning, that are going to go with your practice questions. All right, have a great time there, physics students.